Hi everyone, today we're going to do some algebra word problems, and all of these problems are either mixture or rate problems. So the two tips for these types of word problems are number one, to make tables, and you'll see how to make a table later on. And number two, you can either use one or two variables. It doesn't really matter, whichever one you find easier. So I'll be doing some problems in one variable and some problems in two variables. Okay, we're going to start with this problem. A cashier has 20 bills, all of which are $10 and $20 bills. The total value of money is $220. How many of each type does the cashier have? So here's a table I made, and I just made it beforehand. So what we're going to do here is this is going to be the $10 bill column, and this is going to be the $20 bill column, or the row. And these are the columns. And this is going to be this times this equals this. It's sort of like distance equals rate times time, but the mixture problems aren't always distance equals rate times time. So we're going to do kind of differently. So the part right here is going to be what you want, and you want to know the total value of money. So this is going to be total value of money. Okay, that's the dollar sign. And this side is going to be how much each bill is worth. So how much it is worth. And this is going to be how many bills, number of bills. Because if you multiply how much each bill is worth times the number of bills, you're going to get the total value of each type of bill. So if you want to write it in like a kind of equation form, then you do dollars per bill times bill equals dollars, because the bills cross out. So this is so if you thought about this in distance equals rate times time, then this would be sort of distance equals rate times time, sort of, but it's not the same thing, but just like an analogy. Okay, so how much each is worth is pretty obvious. $10, this is $20. So the number of bills, it says that it has a total of 20 bills. So you can make either one of them x, and I'm just going to make that one x and make this one 20 minus x. So the total value, as I said before, there are two ways of doing this. You can either choose two variables, or you can just stick to one variable. And I'll just show you how to do this when you want to have two variables. So I'm going to say the total value of this is y, because you don't know. And then the total value of the $20 bills would be 220 minus y, because this is the total, sort of like what we did with 20 minus x. Then we're going to make an equation, and remember when we said this times this equals this. So we're going to make two equations, 10x equals y, and 20, parentheses 20 minus x, equals 220 minus y. And this is what we did in the previous video of how to solve these types of equations. So what I would first do is substitution here, because we already have the y equals. I'm just going to substitute the 10x into this. So 20 minus x equals 220 minus 10x. Then I'm going to multiply this out. 400 minus 20x equals 220 minus 10x. Then I'm going to just divide everything by 10 to make it a bit easier. 40 minus 2x equals 22 minus x. Then I'm going to add 2x on both sides. So 40 equals 22, so plus 2x plus x. Then I'm going to subtract 22, so it's x equals 18. Yeah. So x is 18, so this is what we got for this. That means the cashier has 18 $10 bills. So I'll write the answer in green. So therefore, 18 $10 bills. Here, this is the answer, so I'll make a little box around it. And if there are a total of 20 bills, then this value, 20 minus 18, must be 2. So it's two $20 bills. So that would be the answer. Okay, moving on to the next question. This is a distance equals rate times time problem. Riley flew her ultralight plane to a nearby town against a headwind of 15 kilometers per hour in 2 hours and 20 minutes. The return trip under the same wind conditions took 1 hour 24 minutes. Find the plane's airspeed and the distance to the nearby town. So let's make P the plane's airspeed. We want to know um, the distance. Distance equals rate times time. We're going to set the table up like this, and this is going to be against the wind, and this is going to be with the wind. And we're just going to fill out this table. So it says in the beginning, against a headwind of 15 kilometers per hour in 2 hours 20 minutes. So if she's going against the wind, then it's gonna be harder for her to move. So the rate is going to be less. So you're gonna subtract 15 kilometers per hour from the actual plane speed because the wind is slowing down the plane. Then the time it took was 2 hours 20 minutes, and you have to make sure that you keep the variables constant. So this is gonna be kilometers per hour. This has to be hours, and this can be kilometers. So you have to make sure the time is in hours. So in order to make that hours, 2 hours, 20 minutes would be 2 and 20 over 60, but you can simplify that to 2 and 1/3. Okay. The return trip under the same wind conditions took 1 hour and 24 minutes. So we can write 124 over 60, and you can divide by 12, so 2 over 5. Okay. And since she's going with the wind, her rate increases because the wind helps push the plane. So you're going to add the plane's airspeed plus the wind speed. Here you can either choose to add another variable y or d or whatever variable you want to add, or you can do it another way, and I'm just going to do it the other way. I'm going to do this problem in one variable. I'm just going to multiply these two numbers. So I can 2 and 1/3, I can change that to 7 over 3 and p minus 15. So I'm just multiplying rate and time. So I'm going to do that here too. So 7 over 5, p plus 15. And since I only have one variable, I only need to make one equation. So since the distance there and back is the same because it's the same place that she's going to, so I'm just going to make this equal to each other, these two values, because the distance is going to be the same. So 7 over 3 p minus 15 equals 7 over 5 p plus 15. So I'm going to first multiply this whole equation by 15, and then I get 35 p minus 15 equals 21 p plus 15. Then to make it easier, I'm just going to divide that by 7. So 5p minus 15 equals 3p plus 15. Then I'm going to need to multiply everything out. So 5p minus 75 equals 3p plus 45. Then I'm going to subtract 3p, so I get 2p equals, and I'm going to add 75. So 75 plus 45, 10, 12. Okay. Then I get p equals 60. So p was the plane's airspeed, so I'm going to write the answer in blue this time. So the plane's airspeed equals, remember the units, 60 kilometers per hour. So that would be answering this question. Now we need the distance. And in order to find the distance, we're just going to substitute this value into either this or this. Oh, I draw an arrow. So I'm going to do the problem right here. So I'm going to just substitute 60 into that. So 7 over 3, 60 minus 15 equals 7 over 3, 5, 45. Then 7 times 15, which is 5 and 3, 105. So then we get distance is 105 kilometers is the distance. I'm just going to circle that. So that would be our answer. And we did this with one variable only, which was p, but we could have made this y and y because it's the same distance, and then we could have made two equations, and either way would work. Okay, we're on the next question. A car radiator is filled with 10 liters of 40% antifreeze solution. How many liters must be taken out and replaced by an 80% antifreeze solution to leave the radiator with 10 liters of 60% antifreeze solution? So this might seem like kind of a complicated problem, but what I would do is I would make 4 rows, And the first one would be original, the original solution. Then how much is taken out, then replaced, then the final solution. And splitting it up into parts makes it a bit easier. So then the top part would be percentage times total solution, which I mean total amount of solution, which is in liters, and equals the total amount of antifreeze. So the original has 10 liters, and I'm going to write this as a decimal, 0.4. So there's 4 liters of antifreeze in the original solution. Then how many liters must be taken out? So you don't know how much must be taken out. And the percentage is 0.4 because that's just you're taking out the original. So the amount is 0.4x. Then replaced, how much are you going to replace? And it's going to be the same amount as the amount you take out because it's replacing it. The percent is 0.8 because it says 80%, so 0.8x. And your final solution, you want 10 liters of 60%, which gives you 6 liters of antifreeze. So right now we're only going to be paying attention to the amount of antifreeze in the solution. So we're going to make an equation with this, and you just have to follow along. So you start off with 4 liters of antifreeze, and then you're going to take out this unknown amount, but then you're going to add and replace the unknown amount with 0.8x, and then in the end you want a 6-liter antifreeze solution. Then we're going to solve this problem. So 4 plus 0.4x equals 6, 0.4x equals 2, and x equals 2 divided by 4. 10, 2 times 10 over 4, which is 5. So we get the solution is 5 liters. You're going to take out 5 liters of the original solution and replace it with 5 liters of the 80% antifreeze solution. Okay, we're going to move on to the next problem. Solution A is 50% hydrochloric acid, while solution B is 75%. How many liters of each solution should be used to make 100 liters of a solution, which is 60% hydrochloric acid? So I have 3 rows right here. The first one's going to be solution A, and then the second one's going to be solution B, and the third one is going to be the final solution, like the mixture. Then this is going to be the percentage times the total amount of solution in liters, and this is going to be amount of HCl in liters. So solution A, the percentage is 0.5, and then the second one is 0.75. And it says how many liters of each solution should be used to make 100 liters of a solution, which is 60%. So 60% of 100 liters. Okay, so we're going to first multiply this out, and we get 60. Then we don't know the total amount of A we're going to mix with B, so we're just going to label that X. And since we know that the total amount of solution has to be 100, B has to be 100 minus X. Then we're going to multiply these numbers out, 0.5x and 0.75 times 100 minus X. And here you can also write y or make it another variable, but I'm just going to stick to one variable. So the amount of hydrochloric acid, if we mix this amount with this amount, then we must get the total amount, which is 60. So I'm going to write an equation for that here. So 0.5x plus 0.75, 100 minus x, equals 60. Okay. And then we're just going to solve this equation. So we get 0.5x plus 75 minus 0.75x equals 60. Then I'm going to subtract that, and we get 0.25x plus 75 equals 60. Then 0.25x, I'm subtracting 75 from both sides, so negative 15. Then we're going to cross out the negative signs. Then x equals 15 divided by 0.25, which is 1/4. And this equals 15 times 4, which is 60. So now we got that we're going to mix 60 liters of solution A with 40 liters of solution B. So I'll write that in green. 60 liters of A and 40 liters of B. So we're going to mix these solutions to get 100 liters of a solution with 60% hydrochloric acid. Okay, now this is the last problem. Miriem can paddle her canoe 15 miles downstream in 2 hours. It takes her 3 hours to come back upstream. What is the rate of the current? And this is another distance equals rate times time problem because it has time and rate and stuff like that. So we're just going to fill this out. Distance equals rate times time. And there's two things we need to measure. One is when she moves downstream, and the second one when she moves upstream. So I'm just going to write down and up. And we're just going to fill in the information we know. So can paddle her canoe 15 miles. So distance must be 15 miles in 2 hours. So in 2 hours. And it takes her 3 hours, so 3, to come back. And when it says come back, we're assuming that it's the same distance, like back and forth. So we're just going to write 15. So now we need to know what is the rate of the current. But the rate is not only the rate of the current, because you also need to know the rate of her paddling. So we're going to have m equal Miriem's speed, or her like paddling speed, and c equals the current speed. So when she's moving downstream, she's getting pushed by the water, so it's helping her. So we're going to make that m plus c, so she's going to be moving faster. But when she moves upstream, we're going to have to subtract the current from her total speed because the stream is like preventing her from moving fast. So it's like subtracting and making her rate less. So then we can use these two rows to make two equations. So this one is 2m plus c equals 15. And the second one is 3m minus c equals 15. And now we have two equations. So this is like what we've been doing in the previous video. We can either use elimination or substitution, and I would probably go for elimination because it's already in this form. So I'm going to multiply this by 3, and I'm going to multiply this by 2 to make this 6m or the 6c cancel out. So I'm going to multiply the first one, and we get 6m plus 6c equals 45. And the second one, we get 6m minus 6c equals 30. Then, okay, and it asks for the rate of the current. So if we add these two, we're just going to cancel the current out, and we don't want to do that. So we're going to multiply one of them with -1, and we can multiply either one. I'm just going to multiply this one by -1. So we get negative 6m minus 6c equals -45. So you could have just continued on with these two equations right here, but then you would have gotten m, and then you would have to plug that back in to find c. So we're just going to do it a lot easier, and we're just going to multiply that by -1 so we can eliminate m first, so we can just get the answer right away. So we're going to just focus on these two equations that I'm trying to put brackets around. So then we're going to add these two equations. So 6m minus 6m is just 0, and that's the whole reason why we multiplied -1, so we can get rid of the m variable. So negative 6c minus 6c is negative 12c. 30 minus 45 is negative 15. So we get c equals 15 over 12. And we can simplify that. We can divide by 3, so it's 5 over 4. And then we get 1/4, which is also equal to 1.25. So let's write that in orange. The answer is the current speed, the rate is 1.25 miles per hour. Thank you for watching.